this pod, we'll investigate the terminal speed of a falling object.
All objects accelerate at the same rate when they begin to fall towards the Earth. The precise value for this acceleration is 9.81 meters per second squared, but this is often rounded to 10 meters per second squared. The downward force that causes this acceleration is the force of gravity, which is 10 newtons per kilogram.
This means that the downward force acting on an object is its own weight in newtons. When the object starts to fall, there is an upwards force caused by the resistance of whatever the object is falling through. This could be air, water, or any other fluid or gas. This force will increase as the velocity of the falling object increases. When the downward force and the upward force are equal, there is no resultant force, and the object will fall at a constant velocity. This is called terminal velocity.
An example of this is a skydiver jumping from a plane. When the skydiver first leaves the plane, there is no air resistance, and the skydiver will accelerate at 10 meters per second squared. As the skydiver continues to fall, the air resistance will increase, and therefore the upward force will increase. When both forces are equal, the skydiver is falling at a constant velocity, which is the terminal velocity. This is around 55 meters per second, or 125 miles an hour for a human skydiver.
When the skydiver needs to slow down, they will open the parachute. The parachute will greatly increase the air resistance. The upward force will then be greater than the downward force, and the skydiver will decelerate to a safe velocity for landing. A human using a parachute falls at a velocity of around 5 meters per second, which is 12 miles an hour.
You can investigate terminal velocity by using the following method. Fill a gas jar or large measuring cylinder with water almost to the top. Use a crayon or suitable marker to make marks at regular 2 centimeter intervals down the outward side of the jar. If you're using a large measuring cylinder, you can just use the scale on the side. Make sure that the top mark corresponds to the level of the water.
Select a variety of small objects such as small ball bearings, glass beads, small pebbles of various sizes, or pieces of modelling clay. You will also need a stopwatch. The next part of the experiment could prove a little difficult. You'll probably have to work with a classmate and use another stopwatch. Select 2 ranges of depths and label them A and B.
Hold the selected object on the surface of the water and allow it to fall. One person needs to time the object falling through the first range of depths, that's A. The second person times the object through the second range of depths, that's B.
You may need to have several practice attempts to make sure you get it right. When you are satisfied that the reading's sufficiently accurate, calculate the velocity of the falling object for each range of depths and make a note of it. Remember that velocity is distance divided by time. Keep moving the 2 ranges, A and B, to greater depths and take more readings, calculating the velocities each time.
When both readings are the same, the object is falling at a constant velocity. You can plot a graph of velocity against depth. The velocity increases with depth down into the liquid before leveling off as the terminal velocity is reached.
You can repeat the experiment using objects made of different materials. You could use modelling clay to make objects of different shapes. Does the shape have an effect on the terminal velocity?